For basically all of human history, Mars was just this little fiery red dot in the night sky. But, in the last few decades, our view of it has been completely turned on its head. So let's explore the modern Mars, a world that is way more complex and honestly, way more Earth-like than we ever imagined.
Look, our fascination with Mars is nothing new. People have been staring at it for millennia. But what is new is what we're learning about it. We are right in the middle of a renaissance in Martian exploration, and it is completely rewriting the book on our planetary neighbor.
For the longest time, this was Mars. This was the best we could do. A shimmering, rusty-looking disk in a telescope. Its real nature was totally hidden, behind this veil of mystery. It was really just a blank canvas for our imaginations, a world of shifting polar caps and, let's be honest, a lot of sci-fi stories. And this quote just nails it. It perfectly captures the massive shift in how we see Mars. We've gone from just kind of passively observing the planet to actively exploring it, with this whole fleet of orbiters and rovers. We are no longer just looking at a red dot, we're digging in, literally, to uncover the rich, complex history of a world that, might have once been a lot like our own.
So what have we actually learned from this whole new era of exploration? I mean, really, how Earth-like is our neighbor? Well, to answer that, we've got to compare Mars to the planet we know best, our own. So let's get into the data.
Okay, so when you put Earth and Mars side by side like this, some big differences just jump right out at you. I mean, Mars is a pretty small world, right? Only about half the size of Earth. But then you look a little closer, and you see two numbers that are almost identical. The length of its day and the tilt of its axis. And that, right there, is where the story of Mars gets really interesting.
So Mars may be smaller, but get this, here's a kind of mind-bending fact for you. Because Earth is mostly covered in water, right? The total surface area of Mars is roughly the same as the total land area of our own planet. Think about that. That is an entire world's worth of continents just waiting to be explored.
So a day on Mars is just under 40 minutes longer than a day here on Earth, and its tilt is almost exactly the same as ours. Now that tilt is the key to everything, because it's what gives a planet seasons. Just like us, Mars has spring, summer, autumn, and winter. But hold on, if Mars has seasons just like Earth, why is its climate so extreme? The answer isn't in its tilt. It's actually in the shape of its journey around the sun, and this is where the story of Mars takes a really dramatic turn.
So Earth's orbit is a nearly perfect circle. That means we stay at a pretty constant distance from the sun all year. Mars, on the other hand, follows this much more stretched out, kind of oval-shaped path. Scientists call this a highly eccentric orbit, and it is the absolute key to understanding the planet's wild and frankly unpredictable climate.
I mean, this comparison really drives the point home. While Earth's distance from the sun is pretty stable, Mars's orbit is like a cosmic roller coaster. It swings from as close as 206 million kilometers all the way out to 249 million. That is a massive variation, and it has some pretty profound consequences for the planet. And that huge swing in distance, it translates into this staggering number, a 68% change in the amount of direct sunlight Mars gets throughout its year. This single factor is the engine that drives the planet's extreme weather, everything from planet-circling dust storms to these huge swings in temperature.
So what does that do? Well, this extreme orbit basically creates a planet of two halves. The southern hemisphere gets these short, scorching hot summers, but then it gets plunged into long, brutal winters. This intense seasonal change drives huge variations in the size of the polar ice caps, and it can trigger dust storms so big they literally cover the entire globe.
So how in the world have we managed to uncover all these incredible details about a planet that's millions of miles away? Well, the answer lies in this amazing army of robotic explorers we've sent to Mars over the last few decades. They are our eyes, our ears, and, our wheels on the ground.
Think about it. Exploring an entire planet from that far away is a monumental challenge. So how do you do it? The solution turned out to be this brilliant two-pronged strategy. You get the big picture, the bird's eye view from orbit, and you combine that with boots, or in this case, wheels, on the ground.
This is just an incredible family portrait of Mars missions. It's a real testament to our collective curiosity, isn't it? From those early flybys back in the 60s to the sophisticated rovers of today, we have sent dozens of missions to the Red Planet. In fact, besides our own moon, Mars is the most visited body in the entire solar system.
And this image, taken by an orbiter hundreds of kilometers up,
This shows you the incredible power of our eyes in the sky. If you look really close, you can actually see the tiny Opportunity rover and the tracks it left behind in the Martian sand. Our orbiters can see objects as small as a dinner table, giving us that essential big-picture view we need to really explore the planet. And then, from that orbital view, we can zoom right down to the surface and see the world through the eyes of our robotic geologists. This self-portrait from the Curiosity rover, it gives us a real human-scale perspective of the landscape. This is what it would actually feel like to stand on the surface of another world. But Mars isn't just a planet of extreme seasons and cool robots. Nope. It's also home to two of the absolute strangest moons in the entire solar system. So for our final section, let's take a closer look at these little cosmic oddities.
So meet Phobos and Deimos, the two lumpy, potato-shaped moons of Mars. They are nothing like our moon, at all. In fact, they're probably just captured asteroids that strayed a little too close to Mars a long time ago and got trapped by its gravity. They orbit incredibly close to the planet, and that's where their story starts to get really weird. I want you to just imagine this for a second. Imagine standing on the surface of Mars and watching one of its moons rise in the west and set in the east. It sounds totally impossible, right? But it happens every single Martian day. It is a celestial show unlike anything we ever see here on Earth.
So how is that even possible? Well, it's all about speed. The moon Phobos is orbiting so close and so fast that it's actually moving faster than Mars is rotating. So from the surface, it's like you're being overtaken by your own moon, which makes it look like it's flying backward across the sky.
And what would that backward flying moon look like? Well, this image gives you a great sense of scale. Even though Phobos is just this tiny little asteroid, its super close orbit makes it appear about a third as wide as our own full moon. So just imagine looking up and seeing that strange, lumpy object racing across the sky in completely the wrong direction.
But Phobos' amazing close-up view of Mars, it comes with a price. It is on a collision course. The same tidal forces that create that strange backward motion in the sky are also slowly but surely dragging the moon down. In a few tens of millions of years, Phobos will either crash into the Martian surface in a fiery impact, or it'll be torn apart into a ring of debris.
So from a simple red dot to this complex world of extreme seasons, signs of ancient rivers, and a doomed moon, our understanding of Mars has just been completely transformed. But, with every answer we find, we seem to uncover a dozen new questions. What other secrets is the red planet holding? And what are we going to discover next as we continue to explore this absolutely fascinating and mysterious world?